The James Webb Space Telescope is identifying objects in the dark ages that, by the best measurements we have, are large, fully developed galaxies. So, who ordered that? Have you ever wondered what secrets the universe is hiding within? Well, we might have an answer for you because the James Webb Telescope has finally found the edge of the universe. Let's jump right in. You see, the James Webb Space Telescope has been used by astronomers to go back in time to the early cosmos, and they have discovered an unexpected object. 6 huge galaxies that existed between 500 million and 700 million years after the Big Bang that formed the universe were discovered by the satellite observatory. According to a new study released in the journal Nature, this revelation is fundamentally revolutionizing previously held views regarding the creation of galaxies. Turns out, these things are much larger than anyone anticipated in what was once thought to be the early cosmos. Scientists found galaxies as mature as our own when they didn't expect to find anything but tiny, newly created galaxies. How well this telescope uses infrared light to examine the universe because this wavelength is undetectable to the human eye and is able to pick up the feeble light emitted by old stars and galaxies. So, the observatory can literally look back in time to around 13.5 billion years ago by gazing into the faraway universe. This is amazing because the universe is estimated to be 13.7 billion years old by scientists. What many of us had believed to be proven established science has been turned upside down by the discovery of this massive galaxy formation, which started extremely early in the history of the cosmos. These things, which we have colloquially dubbed universe breakers, have so far lived up to their name. Now scientists need to reconsider how galaxies came into being and evolved, since they're so enormous that they disagree with 99% of models describing early galaxies in the universe. According to the prevailing idea, galaxies started out as little clouds of stars and dust that developed through time. For the first time, scientists peered into the very early universe without any concept of what they would discover. It turns out that what we discovered is so unforeseen that it actually poses challenges for science. In fact, it casts doubt on the theory of early galaxy formation as a whole. When the Webb data and the first high-resolution photos of the telescope were made available in July 2022, researchers started examining them. The team was shocked to find the galaxies, and they were so shocked that they believed they had misinterpreted the data when they first saw them as big points of light. Everyone simply dove in when they received the data, and these enormous objects appeared very quickly, almost like they wanted to be found. Taking a spectrum photograph of the galaxies, which includes dividing light into multiple wavelengths to identify various elements and estimate the true distance of the galaxies, is one technique to find out why, how, and when the galaxies developed. The spectroscopy measurements provide us a more thorough understanding of these giant bodies, and a spectrum will instantly inform us of the reality of these things, as well as their size and distance from Earth. Funny thing is, though, this wasn't even close to being at the top of the list of things we hoped to learn from James Webb. Scientists had no idea what they discovered, but here we are. Also, it happened far more quickly than scientists had anticipated. It's also possible that the galaxies found with Webb data are something else. Considering that this is our first look back so far, it's crucial that we have an open mind regarding what we're observing. Even though the data suggests they are most likely galaxies, there is a chance that some of these objects are actually hidden supermassive black holes. Get this, the known mass of stars at this moment in the history of the universe is up to 100 times more than we had previously believed. This is still a remarkable discovery, even if we cut the age in half. Using information from the James Webb Space Telescope, an international team of astronomers has found the oldest and farthest galaxies confirmed to date. These galaxies date back to fewer than 400 million years after the Big Bang, when the universe was barely 2% of its present age. Since the telescope detected light emitted by them more than 13.4 billion years ago, similar to prior observations with the Hubble Space Telescope, the first observations from JWST revealed a number of potential galaxies. Now, 4 of these objects have been verified by lengthy spectroscopic observations, which not only allow astronomers to study the physical characteristics of the galaxies, but also provide secure assessments of their distances. Also, by calculating a galaxy's redshift, astronomers can determine its distance from us. What's that, you ask? The universe appears to be expanding away from us, and the Doppler effect causes distant objects' light to be stretched to longer, redder wavelengths. Redshift estimations can be obtained using photometric methods based on photos acquired through various filters, but accurate measurements demand spectroscopy, which breaks down an object's light into its constituent wavelengths. The new discoveries concentrate on 4 galaxies that have redshifts greater than 10. Hubble's initial observations of 2 galaxies have been confirmed to have redshifts of 10.38 and 11.58, with redshifts of 13.20 and 12.63. The 2 most distant galaxies, both of which were found in JWST images, are the ones whose distance has been confirmed by spectroscopy to date. Redshift 13.2 indicates a time period of roughly 13.5 billion years ago. The near-infrared camera and the near-infrared spectrograph, 2 of the instruments onboard Webb, were developed by scientists who worked together to produce the findings. What more? The JWST Advanced Deep Extragalactic Survey is an ambitious program that has been allotted slightly over 1 month of the telescope's time and is intended to provide an unprecedented glimpse of the early cosmos in depth and detail. In 2015, the instrument teams came together to propose the project. More than 80 astronomers and scientists from 10 different nations were a part of the worldwide partnership known as JADES. Starting with NCAM, the JADES program spent more than 10 days of mission time observing a tiny area of sky in and surrounding the Hubble Ultra Deep Field. With almost all large telescopes, astronomers have been investigating this region for more than 20 years. Nearly 100,000 far-off galaxies, each billions of light-years away, were discovered by the JADES team after they studied the field in 9 different infrared wavelength bands. The scientists then collected the light from 250 weak galaxies over the course of a single 3-day observing period using the N-spectrograph. The characteristics of the gas and stars in these galaxies were disclosed, and exact redshift values were obtained. We can determine the intrinsic brightness of the galaxies and how many stars they contain using these measurements. The construction of galaxies over time can now be fully dissected without knowledge of the early stages of a galaxy's growth. Understanding a galaxy can be challenging. Much like with humans, the effects of these early star generations have a significant influence on later events. This is the most exciting time in history. So many questions about galaxies are being answered by the transformative possibility of Webb. You see, some of the earliest stars would have formed roughly 225 million years after the Big Bang. Since star formation in these young galaxies would have started about 100 million years before the age at which they were discovered, NASA's Deep Space Observatory Telescope is providing a fresh perspective on the cosmos. There's much more we've discovered as a pioneer in scientific research. The James Webb Space Telescope has uncovered astonishing new information on galaxies, planets, stars, and a variety of other fascinating cosmic phenomena. The telescope, which was launched in December 2021 and is expected to operate for 20 years, is just getting started on its cosmic trip. Webb, which is marketed as the replacement for the Hubble Space Telescope, is also setting new standards for scientific enthusiasm by modifying the raw data. People all across the world are sharing its photos or developing fresh insights. Remember when Google, the world's largest search engine, used a web query to test the new Bard AI bot in February 2023? Webb was not the first telescope to directly image an exoplanet, which is a basic point that Bard sadly overlooked. But this telescope also discovered a lot of other amazing things. For instance, Webb was the result of years of labor by NASA scientists and engineers. Launched on Christmas Day in 2021, the several steps of the telescope's deployment in the months that followed also went off without a hitch. Webb revealed its amazing initial photographs in mid-July, which allowed us to observe practically every aspect of our universe, including the farthest galaxies, in greater detail with the aid of the infrared telescope. It gave us a window into the past. Within days of the telescope coming online in late June 2022, scientists started finding thousands of new galaxies that were older and farther away than any previously known ones. In fact, some of these galaxies may have been discovered more than 150 million years before Hubble's oldest discovery. The telescope can also gather enough light from celestial objects, such as exoplanets and newborn stars, to uncover their composition and their trajectories across space. This data has already started to disclose, in great detail, the atmospheric makeup of planets hundreds of light years away from Earth, providing suggestions as to their potential ability to support life as we know it. By analyzing small glimmers of light from close to the beginning of time, the James Webb Space Telescope also discovered what may be the oldest black hole discovered in the universe. The supermassive black hole, which has a mass 10 million times that of the Sun, was found at the heart of a young galaxy 570 million years after the Big Bang. To comprehend how such massive black holes came to be so early in the universe's history is among the telescope's next tasks. There's also a hidden truth about the earliest supermassive black holes, which have been an ongoing area of interest for scientists. An even more exciting revelation is the discovery of galaxy protoclusters. The telescope found interacting galaxies forming a protocluster, which sheds light on the early stages of how galaxy clusters form. Looking to the future, upcoming observatories, such as the Nancy Grace Roman Space Telescope set to launch in 2027, are expected to continue expanding our understanding of the universe. Meanwhile, the James Webb Space Telescope's current discoveries offer a remarkable window into the early cosmos and are reshaping our knowledge of the universe's history. The James Webb Space Telescope, launched on December 25, 2021, represents one of the most ambitious and revolutionary space observatories ever conceived. Its primary mission is to extend and enhance the capabilities of its predecessor, the Hubble Space Telescope, by providing unprecedented detail about the universe in the infrared spectrum. Unlike Hubble, which operates primarily in optical and ultraviolet wavelengths, Webb's infrared capabilities allow it to peer through dust clouds and observe celestial phenomena obscured from view by other telescopes. One of the remarkable features of Webb is its large, segmented primary mirror, which spans 6.5 meters in diameter, nearly 3 times larger than Hubble's. This vast mirror is composed of 18 hexagonal segments that unfold like a giant flower after launch. This large aperture enables Webb to collect more light and observe fainter objects at greater distances, providing deeper insights into the cosmos. Webb's instruments are designed for a variety of scientific objectives. The Near-Infrared Camera, NIRCam, captures images in the near-infrared spectrum, revealing distant galaxies, young stars, and planetary systems. The Near-Infrared Spectrograph, NIRSpec, analyzes the light from these objects to determine their chemical composition, temperature, and other properties. The Mid-Infrared Instrument, MIRI, covers a longer wavelength range and is crucial for studying the formation of stars and planetary systems. Lastly, the Fine Guidance Sensor / Near-Infrared Imager and Slitless Spectrograph, FGS/NIRIS, aids in the precise pointing of the telescope and performs high-contrast imaging and spectroscopy. Among Webb's many groundbreaking findings, the discovery of the earliest galaxies stands out. Researchers have identified galaxies that formed when the universe was only about 300 million years old. These ancient galaxies challenge existing theories about how quickly structures in the universe could have evolved after the Big Bang. Observations of these early galaxies are crucial for understanding the timeline of cosmic evolution, especially regarding the formation of the first stars and black holes. In addition to revealing ancient galaxies, Webb has made significant contributions to our understanding of stellar nurseries. Observations of regions like the Carina Nebula and the Orion Nebula have unveiled new details about the processes of star formation. The telescope's ability to penetrate dense molecular clouds has allowed scientists to observe the earliest stages of star and planet formation, offering new insights into how stars and planetary systems are born and evolve. Webb has also provided valuable information about exoplanets. Its capability to analyze the atmospheres of distant exoplanets has led to the detection of molecules like water vapor, carbon dioxide, and methane. These findings are crucial for assessing the habitability of exoplanets and understanding the potential for life beyond our solar system. The telescope's observations of exoplanet atmospheres are expected to improve as its data collection continues, offering a more comprehensive picture of these distant worlds. Another exciting aspect of Webb's mission is its role in studying the formation and evolution of black holes. By observing the earliest black holes in the universe, scientists are gaining insights into their growth and development. Webb's data is essential for understanding how supermassive black holes formed and evolved, and how they influenced the surrounding galaxies. Moreover, Webb's observations have provided new insights into cosmic phenomena such as supernovae and gamma-ray bursts. The telescope's ability to observe these events in the infrared spectrum allows scientists to study their aftereffects and gain a better understanding of the life cycles of massive stars and the mechanisms driving the most energetic explosions in the universe. The success of Webb also highlights the importance of international collaboration in space exploration. The telescope represents a joint effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. This collaboration has not only advanced our scientific knowledge but also demonstrated the power of global cooperation in achieving ambitious space missions. Looking ahead, the data collected by Webb is expected to continue reshaping our understanding of the universe. Upcoming research will focus on further investigating the formation of the earliest galaxies, exploring the detailed composition of exoplanet atmospheres, and probing the physical mechanisms behind cosmic events. The insights gained from Webb's observations will undoubtedly drive new discoveries and deepen our knowledge of the cosmos for years to come. In summary, the James Webb Space Telescope is revolutionizing our understanding of the universe through its advanced infrared capabilities and comprehensive suite of instruments. From uncovering the secrets of the early universe to studying the formation of stars and exoplanets, Webb is setting new standards in astrophysics and space exploration. Its discoveries are not only answering long-standing questions but also posing new ones, ensuring that the journey to unravel the mysteries of the cosmos continues to be an exciting and dynamic field of research.